So I want to talk about rational expressions. So we're introducing a new adjective today. We've talked recently about quadratic expressions and all their different formats and what the graph looks like. And we're changing gears now as we enter chapter 8, talking about a new kind of expression called rational. So let me define that term for you. And I'll be the first to admit this is an informal definition. This is not super precise, but this will be enough for our purposes. A rational expression is just a fraction that has a variable in the denominator. A variable in the denominator. And so just as a quick reminder, when someone is talking about the denominator of a fraction, they're referring to the bottom portion of the fraction. And the name that we call the top of the fraction is called the numerator of the fraction. Now, the beautiful or perhaps the horrible thing about rational expressions is that they are fractions, so they behave exactly the same way that fractions do. And so what we'll be talking about in chapter 8 is how to add these quantities, how to subtract, how to multiply and divide, and how to simplify these quantities. So take, for example, the case where we're asked to simplify the fraction like this one. There are x's here in both the numerator and the denominator. Let's compare that to if we were asked to simplify the fraction 12 over 16. Now take your time. If you were simplifying 12 over 16, how would you do it? And I'm not looking just for the final answer here. I'm looking for a description of the process, of the steps that you would take to simplify a fraction like this one. 12 over 16, if you factor the numerator and you factor the denominator, you'll see a common factor of 4 appear in the numerator and denominator. And common factors in a fraction can be canceled out, leaving behind 3 and 4. Now, what's the secret? We're going to apply the exact same process to this fraction with variables in it. We're going to factor, and we're going to cancel common factors, just like we did when there were numbers involved. Now, moving through the chapter, when we get into section 8.2, we're going to be talking about how to multiply and divide rational expressions. And the truth is that the process in this example on the right is exactly the same as this process in the example on the left. Take a moment. If you're going to simplify this quotient, 1/4 divided by 1/2, what steps would you take to do that calculation? To divide two fractions, the easiest way to make sense of that is multiplication 1/4 times what's called the reciprocal of the second fraction. Take the second fraction, 1/2, flip it upside down so that it becomes 2 above 1. And that will transform a division problem into a multiplication problem. Once you have a multiplication problem, you can multiply straight across. Multiply one numerator by the other, one denominator by the other, to get 2 over 4, or 1/2. And we'll be applying exactly the same process if our fractions have variables in them. We're going to take the second fraction, flip it upside down. We're going to multiply the two numerators on the two denominators, and then we're going to try and simplify the result. Adding as well. Adding is exactly the same for rational equations and expressions as it was for regular ordinary numerical fractions. Take, for example, 1/5 plus 2/5. These two fractions have identical denominators. Denominators are essentially like units. So this is like 1 centimeter plus 2 centimeters, in total 3 centimeters. Here I have 1/5 plus 2/5, in total 3 of those fifths. On the right-hand side as well, if your two fractions have identical denominators, have the same units, then you can add the numerators, the quantities, together. I have 1 of type 1 over x. I have 2 of type over x. So in total, I have 3 over x. And this is what we will be doing in Chapter 8, these kinds of calculations.